Well, my name is Marco Schorlemer, and I come together with Enric Plaza. We are coming from the Artificial Intelligence Research Institute, which is one research institute that belongs to a large organization called the Spanish Scientific Research Council. The Spanish Scientific Research Council is an organization with institutes all over Spain, but ours is located in Barcelona, well, next to Barcelona. Now, in this talk, has three parts. So in the first, I'm going to talk about semantic heterogeneity. And the second part, and the other two parts, will be two ways of tackling the problem. One will be explained by Enric, and the other I will explain it again, come back to explain it. Since this is a workshop, the things that I'm going to present, or that we are going to present here, some of them are half-baked ideas, things that are related to what we want to do in this project, in this network. So hopefully this talk and with the interaction that we will have in this network will help us to get more ingredients to finish baking these ideas together with what other partners are doing in this network. So the first part is the one that I want to explain is about the semantic heterogeneity. There have been a lot of presentations about, or surveys about what it means, classification, what it means, what semantic heterogeneity means, and what different kinds there are. Here, we have thought that maybe it would be interesting to look at it from the point of view of the meaning triangle, also known as the semiotic triangle. This triangle that describes the relationship between a sign, the concept that this sign evokes, for example, as a human being in my head, about its meaning or its interpretation, and this meaning, how it refers to particular entities, objects in the real world. So there are many different terminologies that have been used for these three different edges of this meaning triangle. I'm going to use these three. And maybe it's interesting, or I don't know, maybe it could shed some light into the problem of semantic heterogeneity, to look at semantic heterogeneity from this point of view. For instance, when we have two agents, being human or artificial, we will have two different kinds of these meaning triangles. And this is probably the standard problem of semantic heterogeneity, where we share maybe a certain piece of reality, certain objects, but two different agents have a different conceptualization of these objects or these entities and use different signs to represent these entities. So we can label that the semantic heterogeneity on shared objects or shared entities. When I say object here, I don't mean physical things. It can also be abstract objects, abstract entities. The other is when we have shared signs, we are using the same signs, but maybe we have also different kind of conceptualizations, and they refer to different kind of entity objects in the real world. So we can label this kind of heterogeneity the semantic heterogeneity on shared signs. And then, since we have three, we could think of maybe a third kind of semantic heterogeneity, which we can call the semantic heterogeneity on shared concept, where although maybe we share the concept that two agents have, they use different signs, and in their real-world practice, they refer to different kind of objects. Okay? So we could look at semantic heterogeneity from as these three different kinds. Now, when we want to achieve semantic integration, we can see how we can put these two triangles together. Okay, so one sort of semantic integration is when we already get some sort of overlap of these triangles. For instance, when we have this situation, which I put these things in quotes because I just put a label. Maybe it's not the right label to put it in, but let's call this semantic integration communication. This would be the usual situation where an agent sees a sign or expresses a sign. This evokes in this other agent a concept which refers to the same object that the other agent was thinking about. Maybe if we look at humans, the concepts are in our different heads, so we don't know if exactly coincide, but I'm talking about some objects and the other's understanding that I'm talking about the same objects. So this could be some sort of semantic integration. The other is when now we have this situation of overlap in these triangles. Let's call it translation. I don't know if this is the right word, but let's call it translation. That would be the situation where we have two agents using different signs, but there's an agreement on the concept that they represent and the objects they are talking about or they're standing for. So we know that we can translate between one sign and the other. So a multilingual situation could be like this, where we have two different words in different languages, and we know now how to translate from one sign to the other. And the third kind of semantic integration is now what we have called agreement, just to put a name, which is that two agents, although they work on different pieces of the reality or objects, in some sense they have agreed on what signs they're going to use and what concept these signs evoke or represent. Now, with giving this view of semantic heterogeneity and semantic integration in terms of these meaning triangles, in this talk we're going to talk about, and then there's this perfect semantic integration, which is everything coincides, which is probably the hardest thing to achieve. Now in this talk we are going to talk about two different ways to tackle semantic heterogeneity, and we have somehow placed them in these two different ways of achieving this integration according to these meaning triangles. One is what Enric now is going to explain, the notion of concept convergence towards an agreement, which would be that we start with a situation where we share the signs, although maybe we have a different conceptualization or different concepts for them. They represent different objects or different entities. And we try to converge to the same definition of concept or the same representation of concept. So that would be one way to tackle this semantic heterogeneity, to get this agreement on the concepts. So that we get this final semantic integration. And the second one, which I will explain after Enric, in order to be consistent with the terminology that I've been using here, I will call it the object convergence towards translation, which would be we share probably the same framework for representing the concepts and have different signs though, but we try to find the same converge on the objects so that we have a situation where we know exactly what sign has to be translated to another sign to get this sign translation situation. Now this is very abstract description of the problem, but now with these two different ways to tackle the problem, we go into the specific details what we mean about these two different approaches. So I give now the floor to...
Okay, I'm not going to talk a lot about all the work we have done before. I just want to say I come from machine learning, and we have been doing some work integrating machine learning and computational argumentation that it will show up here. But essentially, the project we proposed to this network is this idea that meaning as a kind of agreement in a particular context. So a kind of social agreement. Although we are going to focus on just two agents talking to one another, which is the simplest scenario. The idea is to look at the ideas from semiotics and what's the name? And anthropology, and try to set up some goals that more than technical are not philosophical, but in the domain of meaning. So instead of working on solving problems like alignment or matching or interoperability, we want to define our problems in the sense of when do agents really understand each other, how can agents adapt their meaning to particular contexts, and how they can reach agreement in particular contexts of the meaning of a concept. So the idea is, as I said, going from technical positions towards ideas from semiotics and linguistics anthropology. So one idea that's more or less the basis for this project here, it comes from ethnographic studies, which is the idea of segregate and the idea of a context set. So the idea is that when you are working in a particular context, in a particular domain, we partition the world in a particular way, okay? That's the meaning for me that the meaning of context, of concepts is contextual. In a particular context, we reinterpret the meaning of concepts to set up a context set in which it separates different objects that we are dealing with in a way that it's useful for our particular purposes. So we have the segregates, and then the set of segregates that defines our domain, which is, it's called the context set. So one example of this is that you go to an American eatery and you discuss with the waiter what kind of thing you can have. You can have some sandwich or whatever. And then finally the waiter gives you something and you say, hey, that's no hamburger, that's a cheeseburger. So we have had some kind of misunderstanding with one another, which is strange because if you think of this example in using an ontology, a hamburger is a kind of general idea of a concept, and if it has cheese, then it's a cheeseburger. But in this particular context, the sign hamburger has been changed their meaning from the standard one to one that it's more useful for a particular context, which is basically being in an eatery and you have different kinds of things that you want to sell, and then you use signs to express the different kind of objects you want to sell. So you can have hamburger, ham sandwich, apple pie, whatever. So we have disagreements, we reach some disagreement, and what we want to focus now is in coming up with some computational model of a process by which the agents talking to one another, arguing with one another, they can first detect that there is a disagreement on the meaning and then reach an agreement of meaning. It's not like in other forms of argumentation, for instance, in persuasion, in which one wants to convince the other that my meaning is the good meaning. It's just that we are trying to set up a context in which we understand each other. When we say cheeseburger, we mean this, and when I say hamburger, I will get the other thing. That's the only thing interesting here is to understand each other. So this is the problem to solve, understanding each other. And how we can reach this. The idea is to have a mutual adaptation. So each one comes from different ontologies. So O here doesn't mean object, but ontology. Sorry about that. And there's a subset T, which are the concepts that seem to apply in our context in here. And then we have to adapt each other, those the meanings of those concepts until both we understand each other when we say hamburger, cheeseburger, or a chair, or whatever, that we are agreeing on what we are denoting by the signs that we are using in this particular context. So why adaptation? So my idea here is that, well, in fact, there are no such things as ontologies, I think, and this, at least in the sense a lot of people is working on. In cognitive linguistics, they say that the traditional approach to meaning was the idea of a dictionary, and in fact, we should be moving to the idea of an encyclopedia. So the meaning of a concept or a word is all our real-world knowledge that is related to that object and the relations with actions and other different contexts. So why adaptation? Well, we say that meaning is contextual. That means that it's not fixed. Thus, we have a number of meanings. On the other hand, there's no fixed number of meanings in principle, if meaning is contextual. Therefore, if we have to understand each other, we will have some kind of vocabulary or encyclopedia in our back, and it can be enriched with time, but we will always require at some point adapting our definition of the concepts to understand each other. So the work we did in concept convergence comes a little bit from machine learning. The idea is that you have a language in which you can describe individual observations or objects. You have another logical language in which you can define some formulas that describe classes of objects. That would be the intentional descriptions, like you can describe what a chair is and how it's different from an armchair. And the concept convergence is two agents that meet are using the same symbol S, but they are not far away, maybe, about the meaning, but they are not completely in agreement with one another. And the basic idea here is that each intentional description formulated in some particular language covers or subsumes or is consistent with a set of objects that is known by a particular individual. And then the idea of convergence is that to have a convergence from the meaning from one towards the meaning of the other agent in both ways, left and right. So in this case, the concept B prime would be aligned or would be consistent with the intentional descriptions of the first agent and also with the particular objects known to the first agent. And how we can do that, basically with the idea is using argumentation. So particular rules describing different sort of concepts can be exchanged in communication. The other agent can agree or disagree, can challenge the definition with a counter argument, or it can provide counter examples of the definitions of the other, or new examples that are unknown to the experience of the other agent until you reach convergence, which is, it can be mostly or often just an approximate convergence. I mean, it doesn't mean it's 100% equal, but for most of the cases they are dealing with, they can accept that they mean the same thing. So that's the idea, that we'll adapt a set of concepts. In the image of triangles, like in here, basically what we're trying to do is to change the intentional definition of the concept or the meaning of the concept so that it's consistent not just with the objects we know, but with the objects that are known by the other agent, or at least by the ones that are put into the conversation. And when you reach the convergence, it means that basically you have reached a good matching between the two intentional definitions that need not be the same, but need to be at least coherent or consistent with everything that has been said in this process of conversation. So there's another thing, of course, which is the idea of encyclopedia, which is basically, I think, the idea of there are contexts, but then there are recurring contexts. Okay, so contexts that appear again and again. And one example is the definition of a planet. We have the historical definition of a planet, and now we have the new definition of a planet, and Pluto is no longer a planet. And we have both of them in our mind. We just need, in our scenario presenting here, not decide which one is the best. We just need to know which one we are talking about just to understand each other. So basically, that means that from some kind of vocabulary or encyclopedia that we have basically the most typical or frequently used meanings of particular signs, we can also have adaptations that are helpful to us to keep in our encyclopedia, in our memory, because they keep reoccurring after then. In these cases, you don't have to develop a new meaning, you just have to recognize that it's the meaning that has been used in past occasions. So in summary, we want to explore this idea that we don't have a fixed meaning. The meaning is contextual, means that some adaptation needs to be done on our definition of the concept in order to understand each other's. And again, the idea is not which one is better or that one convinces the other, but just to settle a particular agreement that in this particular context, we are going to understand each other with this vocabulary. And Marco is up again.
So the other approach that we want to further explore in the context of essence is what it's a few years old already, but I think it has still a lot of potential to be further explored. It is about finding semantic alignment or semantic integration when we look at the interactions of two agents, for example, situated in their protocol, so in their interactions that they have. The idea is that how to look at this relation between meaning and interaction. Very roughly, we can say that the traditional semantic web linked data vision would be, if we want to interact, we need to have first an agreement on the meaning. On the we write ontologies, we find semantic alignments, and so on. But sometimes the meaning of a particular term is very, very interaction specific. It has a concrete meaning in a particular kind of interaction, in a particular kind of moment of that interaction. And so we were exploring this to explore a complementary route, which would be, instead of taking shared meaning as a prerequisite for successful interaction, to look at how shared interaction generates a shared meaning. Okay, somehow it is, we can say it is sort of a Wittgensteinian approach where we look at the meaning of a word, how it is used in a particular language. So this is the kind of approach that we have been looking by understanding that the word that I'm using or uttered, or that I've uttered, or that or the terminology that I'm using is very linked to the actions that into which they are woven, and that expressing a term is something of an activity that is done within the context of a so-called language game, as Wittgenstein was calling it. So the basic idea in this approach is that we are going to look at how to semantically align words that are used in the context of an interaction between two agents, to take the simple case, and how these words that are used in this interaction are linked to the actions that these utterance of this word produce in the deployment of or the unfolding of the interaction. So we look at, as already Michael said at the beginning, the view of words as uttered, that as speech act, so that their utterance changes some kind of state in the interaction that we are having between two agents. So to give you a very, very, very simple example of the idea that we are exploring is imagine a very simple bargaining interaction, bargaining language game, bargaining protocol. Very, very primitive language between a seller and a buyer. This language has only 4 words: start, offer, accept, and refuse. And there is a protocol to follow this bargaining, which is represented as a finite state automata. Very, very simple. I started state, the conversation, the communication starts as 0. The seller says start, the buyer can refuse, and then we don't bargain. Or if the seller has start, then the buyer can offer a price, which then the seller either accepts, then the bargaining is finished, or it makes a counter offer, and the other offers again, and so it goes in circles until maybe either the seller or the buyer accepts. Okay, so in these terms, in this context, in this particular interaction protocol, refers to the meaning triangle in that way. So here, the signs would be these utterance, these words that are uttered. The concept or the meaning of, or the interpretation of these signs is taken in the context of an interaction model. So the interaction model is the context that provides, or the conceptualization of these utterances. And the utterance stand for particular state transitions in this interaction model or in this protocol. So that means that if we are in a situation, for example, where we have a novice tourist that comes to a bargaining situation and has a little bit slight different view of how to interact, he has this view of an interaction protocol. You just offer, or you take counter offers, or at the beginning you can say no, or you can buy something, okay, or the other way around for the seller. Now imagine that we have these 2 agents. One is talking in English, the other is talking in Catalan, and the one I've blended in the more complex interaction model of the seller, of the local person in Catalonia trying to sell their products. Now these two interactions have different views of these terms or words and how they can be used in these different interactions. So one way to see how these different terms would match is to look, when do these words make compatible state transitions? Okay, the mathematical object that so the idea is, the situation of semantic heterogeneity that we have here is that we have different signs, different words for these utterances. The utterances represent different state transitions, but we have the same understanding of what an interaction model is. Okay, in this case, a finite state automata. We have the same understanding of what is starting and what a successful state is in this representation. Now, what we want to do is to make an integration. In this case, it is, in the terminology that I used before, an object convergence, because we're going to share the interactions and see, by sharing these state transitions that we are doing in the interaction, to find out how our signs align. Okay? And this technique, we have called it under the name of interaction-situated semantic alignment. The alignment or the integration that we want to achieve is that we have a shared understanding of what an interaction is. We have shared specific state transitions of particular interactions, and that has helped us to align our different signs, our different utterances. So if we have these two automata, the mathematical object that would represent this integration is to take the product of these automata, respecting initial states, final states, and state transitions. If we make this product, we get this one, and then if we look at the pairs of the labels, what we have is an alignment of these terminology. This is when these different words trigger compatible state transitions that will eventually lead us to a final state, assuming that reaching a final state is a successful interaction. But and from this automata, by looking at the words from initial states to final states, we can find an alignment of the terminology which is based on compatible interaction, so on shared interaction, transitions of this interaction. But obviously this is not something, this is the kind of object convergence that we do, but this is not something that you can compute realistically, this kind of product automata. This is our mathematical object, our aim. But we have developed a method that in context of essence we would like to further develop, which is, since we have no access to what the other idea of the other protocol that the other has, what we're going to do is, while we are interacting, to find out what the alignment is. The idea is, if I receive a word that I don't understand, but at that particular situation of my protocol, I was expecting A or B, and the other says C, then I just assume that it is A, or I assume that it is B, and carry on forward. If we end up to a final state, this is a success in our interaction, so I was lucky in my alignment. If we don't reach a final state in our protocols, then it was not a good alignment, and I have to drop that alignment. So the idea is we had some kind of meta-level alignment interaction model protocol that is controlling this technique. I skipped that, and I skipped that. And I just want to conclude saying that somehow what we wanted to explore with this, and it is, I mean, this is basically the initial ideas and the mathematical model were well developed by Manuel Atencia in a PhD thesis that a few years ago, is the possibility to complement classical approaches to semantic alignment, which usually take a more model theoretic understanding of meaning and that put having ontologies or shared meaning prior to successful interaction, with this more, let's say, Wittgensteinian view of meaning, where the meaning, how it is used in a particular language, in a particular language game or protocol, and to look how this interaction or this shared interaction helps us to find a shared understanding. And therefore, the research challenges that we would like to work within this network is, first of all, the initial approach that we have done is a very, very simple understanding of what an interaction is. We have only used the notion of a finite state automata, and the successful interaction is reaching a state, reaching a final state. But obviously, in richer protocols, we have more commitments that have to be satisfied in the middle of these interactions. And all these more expressive models of interaction can be a very valuable input to find out semantic alignments. Then, more expressive communication language. I mean, the examples that we have shown here and what we have explored were based on some simple propositional languages. Obviously, that has to be, we have to go beyond that and go to richer communication languages. Also, more sophisticated understandings of success and failure of an interaction. As I said before, now we are just assuming that we both reach the final state of our interaction, but there can be more sophisticated understandings of what success and failure is. And then something that, another challenge is how to combine that with other semantic alignment approaches. This is something to explore in these research visits that we want to do together. Our early stage research is going to visit Trento, and Trento's early stage research is going to visit Barcelona. So this will be help to find a combination of more standard semantic matching techniques together with this more interaction-situated approach. And obviously, deployment and evaluation in realistic scenarios. And that is, here we were hoping for our visit of our ESR researcher to our associated partners who would provide particular real case scenarios of interactions where we would like to look at. So any of these challenges provides for room for lots of PhD theses, I think. So really that is, it's a simple idea that we have not continued working because of lack of funding and human resources, but I myself believe that it can be interesting to explore a little bit further. That's it. So that is what we wanted to say. So if there are questions.
Hi. Very interesting. So I was wondering, have you ever applied your method, your models to actual natural language communication?
Not to natural language communication,
to human communication, I mean.
But to very simple artificial agent communication and protocols. We have made experimentation with artificially generated protocols and labels on these transitions, and then explored extensively how the alignment is reached by repeated interaction between these agents, but with particular agent protocols and very simple agent communication languages, not human or complex.
Yeah,
human
okay,
languages.
this is the answer I was expecting, but I mean, I see here that you have taken inspiration from stuff that actually comes from looking at human interaction. Now you apply it to artificial agents, but it actually seems to me that it also has potential for explaining and modeling stuff that goes on in human communication. So anyway, you have not done it, but I think that there could be some potential for actually explaining human
Okay,
dialogue.
but if it is, I will be happy to discuss this and to explore this in the context of this network, because that is the reason for that. But we haven't done it because we are not natural language experts in our institute.
Okay, sure.
So when you come up with your triangle of meaning, I was sort of objects, concepts, and signs. But in the end, what you actually do is that your objects and your concepts, they look actually very much, they're kind of the same type of things, right? They're not that different from each other. At least in your theoretical thing, they say, oh, the objects are just finite state machines, and the concept, it's basically the product of that, but that's also a finite state machine still, right? So traditional semantics, you would think of objects, right? So the meaning of a term is a set of objects, while the intention of that is a set of features. So what I would actually expect is that you use something like, I don't know whether you know this, formal concept analysis, and then you see, oh, people use these words for these objects, so they must have these types of concepts for that. And then convergence would maybe be reached. But you never thought of this type of model for looking at convergence. Translation and communication.
As I said,
it seemed in a sense so obvious.
Yeah. As I said, in the description with these meaning triangles, I already make a warning that it is half-baked ideas, and I must confess that we have cheated a little bit and tried to describe the things in this context. And somehow, at least I don't know with the concept convergence, I think that there's one way. In the term of these interactions situated semantic alignment, this is really what is happening. I mean, and here in the way in which the words are looked is how they represent particular transitions, you would say even transition instances of particular protocols, while the concept is provided by how this utterance is understood in a protocol. Okay, so the protocol is how the protocol that I have is how I understand this utterance in this context of the protocol. So, but it will refer to particular transitions. Okay, and in this way we have tried to make the convergence. Not in the way of formal concept analysis where a sign represents particular objects, okay, so that particular, but this, how this word stands for a state transition. That is the way we were looking at, because we were looking at in the interaction. That is the idea.
So I was wondering if you've thought at all about how you're going to detect, given that one agent can't observe another agent's model of interaction or their mapping from signs to concepts and objects, how you're going to detect that something's gone deficient with the way you've aligned. So I'm thinking within the realm of natural language, the kind of conversation that can happen is three guys at a bus stop and one says, windy, isn't it? And the other says, no, it's not, it's Thursday. And the third says, yeah, me too, let's go for a drink, right? So, they can be talking at cross purposes and kind of not realize. And in your example, where you had one agent who was able to refuse an offer and end the game that way, whereas the other agent, in the end, they're going to accept something. They could go through endless cycles of offering and counter-offering, but a deal will be done in the end. These agents won't notice they have a different model of bargaining unless one of the agent who can, in the end, make a bargaining process futile and say, no, I'm done. I don't like any of your offers. They wouldn't even notice. So have you thought about how you're going to detect when alignment's gone wrong?
Yes, so the crucial notion here is, as you said, what we understand under a successful or a non-successful interaction, okay? So I can only find out the level of alignment that my model of interaction allows me to find. The one that I've explained here is very simple. It's a finite state automata. And the only notion of success is that each agent has reached a final state in their protocol. Okay? If they reach it, this is a success, so the alignment is the one that you find out. If you want to have a more richer way to find problems like the ones that you have been mentioning, then I probably will need to find, for example, in the bargaining, that when I accept, at some point when I say I accept this offer, there's a commitment that I pay for this good, and that this money, there will be a money transfer from the buyer to the seller. Okay? This I don't check here. But if my protocol allows me to represent these things, then I would be able to find if I have been successfully understood when the other said refuse and the other said buy, and I have aligned it and we have reached the final state because we finished the bargain, only that one was expecting to receive a payment and the other not. So if I have this more additional information in the protocol, I would be able to find this failure as well and improve the alignment. If I don't, I won't be able. So that's why, although it is a very simple model and it already helps us to find an alignment, my belief is that the alignments will be much more accurate and much more good and richer, the more richer is the model of interaction that I have and that I be able, so that I can find out. But it is crucial to agree. That is the agreement of the concept, let's say, the agreement of the interaction model. There must be an agreement in that sense of what we understand as a successful interaction or an unsuccessful interaction. Does this answer what you were?
Well, kind of, but you, in your answer, are going very much into the specifics, the domain specifics of a bargaining game, and the fact that, in the end, money will be transferred or not, and that you will be violating some protocol. I was hoping for an answer that's much more in lines of how you're going to manage expectations and violations of expectations more generally in a kind of domain-independent language, and use those violations of expectations to distinguish between, well, I've just got to revise my Bayesian posterior probability distribution over his network or interaction protocol versus I've got the wrong language here for describing his interaction protocol.
But that would mean that you would need some kind of agreement of what these notions are, expectation and violation of these expectations, which would be the ones that guide the alignment. That is the idea that I wanted to mention. But I mean, we can discuss that maybe on the coffee break, but I would be happy to listen to that.
There's a very simple-minded and probably very stupid observation about the bargaining situation, which is it's a negotiation about a boundary. So if you say, what's the value of this object? And you're looking for a boundary between too cheap and too expensive. And both people have different interests, but they also have different perceptions of where that boundary lies. And they're going to find different positions along in a space. And they'll end up at a particular point, but the point they end up in is somewhat arbitrary. And that seems like a reasonable analogy with often what happens when we negotiate meaning, that we have a space of possible alignments that we can make, and the one we choose gives us a rough approximation, but it's very context dependent. And I'm wondering if there's some way of abstracting, not on the notion of interaction, but on those different choice points that are reached to come up with some idea of how there's an interplay between negotiation, vagueness, and meaning.
I don't know if I've understood exactly what you were pointing out, but we yeah.
Different valuations, right?
Yeah.
Of the extension of too cheap versus expensive, and trying to find, there isn't a fixed notion of the price of this object.
Yeah. But in the context of this particular example, this was not an issue. Let's say, yeah. Okay.